Hey guys, and welcome to the show. Today I'm in Mountain View, California at Ames. See, that's a real astronaut right there. Not really. But today we're going to be building a VPN with Ryan Barry. We're going to connect your network with your Azure network. Hey guys, and welcome to the show. I am here with Ryan Barry. Ryan's going to help us set up a VPN between your network and Azure. He is in his home office. I'm in space. How's it going, Ryan?
It's going well, Lex. How are you doing?
I'm coming to you live from the International Space Station.
Yeah, that would actually be pretty cool if you were floating around. How cool would that be?
Perform an Apollo 16. I'll just kind of.
Yeah, that would be epic.
Weightless. Oh, here we go. How you doing, man?
I'm doing well. So I know last time we had a lot of fun and kind of simplified things a bit.
Yes.
Yeah.
And the reason that I wanted to do that is because, you and I set up Azure environments all the time. I do it. I've got a test lab that I just set stuff up in. And I just want to make sure that if somebody's out there and this is the first time that they've set it up, they understand how to do it and it's simple and straightforward.
Yep, easy enough.
Yep. Okay. So we talked last time about creating an environment. We created one. We learned some really cool things about management tags and rights that you can assign to resource groups. Really cool stuff.
Yep.
And so now what I want to focus on is getting connectivity to that environment. Everybody, I think, watching this, and if you don't know, you're about to find out, knows that you can RDP into virtual machines that you set up. But that's not really, that's great if you want to create an environment and VPN into machine A and manipulate things in your own little private network. That's fine.
Yeah, if you want to build, or if you want to build an island out in Azure.
Right. Yeah.
That works very well for some workloads, but that's not typical for the.
To actually set up servers and use them as if they were in your own local data center, you have to have connectivity.
Correct.
And that's either going to be with a VPN or with an express route.
Yep. And we have another vehicle that we're not going to talk about, software-defined networking.
Yeah.
So the Cisco and other vendors have solutions for building, basically a private extension of a layer 3 network into other, another hosting provider or into the cloud. We support that also. We won't talk about that today, but that is a third option. So
yeah. Okay.
Yeah.
All right. So let's keep it simple today. I think most people are going to probably opt for the VPN solution.
That's the path of least resistance. Certainly doesn't require any special circuits to be put into place, doesn't require carriers to be involved, doesn't require other parties. And in fact, one interesting note about VPN that I don't really have a good way to demonstrate it, but you can actually, so like, say you build a network in Azure initially, connect up with VPN today, and then maybe that starts expanding, the use of the resources in Azure starts expanding, and you want to increase the amount of capacity you have, for bandwidth, and you want to move to ExpressRoute. You can swap out VPN and plug in ExpressRoute, very little to no downtime, and leave those resources running in Azure as they were. So that is also an option to kind of migrate from VPN to ExpressRoute.
Awesome. All right. So without further ado, let's get that VPN set up.
Absolutely. Let's talk a little bit about how that works and what options exist to kind of wire that all together. So Lex, this is a slide that's got a lot of stuff on it for sure, but it's representative of what a lot of customers you and I work with, might have deployed in their on-premises environment today, and perhaps even making use of services or having network resources rather deployed into maybe a colo facility that they might have with some sort of connectivity in the middle. So on the orange box on the left is just showing all the infrastructure that's typical of a customer running on-prem. And on the right is the plethora of things that exist in the world of Azure that customers can take advantage of. Certainly, what we've talked about last time with just virtual machines, hundreds of other services that can be made use of in Azure. Many of those services can actually be connected or wired directly into a private network. Last time we built a private virtual network in Azure, you can deploy an Azure website that's running as a service without a virtual machine that participates in that network. So, lots of these services actually can integrate with networks to allow you to access private resources without, exposing them publicly.
Yeah.
What we're going to talk about is the stuff here in the middle. Actually, there is a store simple. I'm not going to talk about, but there is some options for being able to replicate storage and extend storage. We have some additional solutions that exist today with NetApp and so forth, but that's kind of out of scope for today. It's really just these top two boxes: the site-to-site VPN, point-to-site VPN, and ExpressRoute.
Okay.
So given a network on the right in Azure, one way that you can connect is a simple way you can connect is just point to site. Think of this as you have road warriors on the road, with their laptops, and they want to be able to punch in from anywhere, from a Starbucks or a coffee shop, whatever, and be able to access these resources as if they were sitting on a corporate network. Azure has, as a service, the ability to provide and surface point-to-site connectivity, as a capability to customers, and customers can use that in conjunction with site-to-site VPN, which we'll talk about here in a minute. So site-to-site VPN allows you to create, to use physical devices that you might have in your data center today, like a Cisco, Checkpoint, Fortinet, Barracuda, insert vendor here, that can support connecting to our gateway service in Azure. And when I say gateway service, you can certainly run a virtual machine with Barracuda or Checkpoint or some sort of software-based VPN solution on it. We support that. That's no problem. We have customers doing that. They might know how to manage, Barracuda on-prem today. They want to extend that into Azure, but we certainly support that. We have a capability called a virtual network gateway, or VPN gateway. And that's basically a VPN solution as a service, and it provides both point-to-site and site-to-site VPN connectivity as a highly available offering. So if you wanted to build out a Cisco appliance in Azure and make it highly available, you need at least 2 virtual machines. You need to go to Cisco and actually license the software. You need to patch the machines that software's on. So there's some overhead that comes along with that. So using the solution we have in Azure, you just go through the portal, little wizard to kind of indicate what network you want it to be associated with, and we surface an external endpoint that your appliance on-prem can connect to. So those are kind of 2 VPN-based paths. Cool. The other option is ExpressRoute, and this is what we were talking about, this kind of the express way that you can access, it's a direct link that you can access resources in Azure from a 50 megabit circuit all the way up to 100 gigabit circuit. So this pipe can be small to massive, and you can also scale it as your business needs grow, or resources you deploy in Azure grow. So the ExpressRoute does require some collaboration with carriers, setting up some circuits to be able to establish that private connection to us. So as an example, it's typical for a customer to use like a US signal as an example, not to say that they're any better over another, but it just happens to be one I worked with recently with a customer. So the customer was using US Signal as their carrier. US Signal has some partnerships with our exchange providers, and what an exchange provider is, a good way to think of it, is a big patch panel where they've got carrier circuits coming in on one side, and they have our core edge routers sitting in their demarcation point in one of their facilities, and they can stretch a piece of fiber or a network cable from your equipment at the exchange provider over to a port in our core router, which actually sits in our private backbone. So the benefit of this is that it's a service level agreement backed circuit. There is zero traffic that would traverse over public internet connections or circuits, so it's entirely private, and it's dedicated bandwidth. So there's some variability when you use a VPN-based solution because you're relying on the public endpoints of the internet. So any questions about that? I think we should probably.
That makes sense.
Yeah, let's dive in and see how it works. All right, so what I'm going to highlight first is, oftentimes IT guys get pretty excited about what sort of hardware people have and what that hardware's capabilities are and all that kind of stuff. So I thought it might be good to start with what I'm using here at my home. There's a company called Ubiquiti that has some what I would deem as kind of enterprise-ish grade equipment at a fairly low cost. Lots of small businesses use this equipment, hotels and so forth. They have a pretty powerful router that you can purchase pretty inexpensively. This is $129. This is not like your typical Linksys or router/access point you might get at Best Buy. This is only a router. And this is actually what I use as my, to provide the internet connectivity for my home. And it does have some very powerful capabilities to set up, BGP and IKE based, connectivity over VPN, which is what I did into Azure. So that's what I have in my basement, using Comcast as my provider to actually connect up to Azure. So let's walk through what I've got on the Azure side and highlight what I've got running. So what I have is this is a resource group called Skynet, and in this resource group I've got a couple of virtual machines. You can see I've got Skynet North 2. I have one in the West, and I also have one running in Europe. And we'll talk a little bit about why I have 3 of them deployed in 3 different locations in a bit. I'm going to focus on the North VM. That's where I'm going to actually highlight kind of what I set up. So in this resource group, I've got a lot of other stuff. You see the IP addresses and the network security groups, what we talked about in our last show. But I have some other services that I've introduced into here, specifically this virtual network gateway. So this is actually where I was talking about the capability of Azure that's native to Azure, doesn't require any virtual appliances or licensing with other vendors to be able to set this up. So let's click into this and talk about how I set this up. So this VPN gateway is running in a network that I have in the North data center. Let me get down Skynet VNet. So let's go ahead and look at my network. So this is similar to what we set up in the last show. And in this network, this is a 172 network, and it's /16. So it's a pretty big virtual network space that I've defined in Azure. And there's a couple subnets on this network. There's a couple networks that I have some website services running on. The North subnet, this is actually where my VM is sitting. And I'll prove that to you when you see the IP addressing here in a bit. And make this a little bit bigger for everyone. And there's also this other network in here. This is gateway subnet. So in Azure, regardless of whether or not you're, let me scroll over a bit, whether or not you're using a VPN or ExpressRoute, you need this gateway subnet. So this is the subnet that we deploy some resources to be able to establish that beachhead connectivity from the exchange provider, or from if you're using VPN. As I mentioned, VPN, our gateway service is highly available, so we actually have multiple endpoints that we run in that gateway subnet. So it's more than just one IP that's going to be used. So you see, this is definitely an oversized network that I could reduce the size. I think you actually I can't remember if it's /28. That might be the smallest that you can go. But I have 250 IP addresses in this subnet because I have a pretty big network space that I've established. So if you have a network, to create this special gateway subnet, you notice there's a button to add a subnet, and there's a special button to add a gateway subnet.
Yeah.
So you need to do this, and it's grayed out because I've already done it.
Okay, so I have a question for you. So
sure.
Just to recap, your original network is 172.16 172.0/0/16. What's your subnet mask?
Yep, 172.16 and then /16.
Okay, so then we've created two subnets and then a gateway subnet in that address space.
Correct. Yep. So my VM sitting in here,
right,
in the 1600. My gateway subnet is 2.0.
Okay, great.
All right, so that's kind of step one. So last show we mimicked this. We created a network and we created two subnets and we deployed two VMs. This is equivalent to what we set up on that last program. That basically I have a VM sitting in a subnet. The difference is we have the special one in this case. So that's step one. Step two is you need to add a virtual network gateway. And the way you do that is literally just by hitting add and type in virtual network. And actually I can do that just to show you. Maybe we can go through the wizard instead of just walking through what I already had set up. Just type in virtual network. There's the gateway. So this is the endpoint that we have as a service. And I'll just start the wizard, and then I won't hit create. I'll kind of walk through what the options are, and then I'll show you what I have set up. So you give the network a name, and this is where I talked earlier about how the gateway actually behaves the same if you're using a VPN or ExpressRoute. You just basically mark it as such. There's some technical things that are different under the covers with ExpressRoute to be able to allow us to to set up BGP and all the ASNs and so forth. But in my case, I just selected VPN. And then there is a route-based and policy-based, and basically this has to do with if you're using BGP and traffic selectors. Route-based has some capabilities to be able to allow you to create active connections. So typically, VPN connections have a point of failure. So if there's if you have a piece of hardware go down, you don't have a path to get to the network services you have in Azure. So route-based VPNs support active connectivity where you can have failover to a backup device. So there's quite a bit of flexibility with route-based VPN. You can also have multiple connections back to different sites. Policy-based is just pretty straightforward. Advertises route to your network of how to get to Azure, and it's just a kind of a simple point-to-point type path. So I set up a route-based network. And then there's a couple of options for SKUs. I have my network set up to be a basic, and one of the big differences between them, there's two differences in it. One is a number of connections they can support, number of sites that can connect into this gateway, and then also the amount of aggregate network traffic that they support. So basic can support up to 100 megabits. I have a 400 megabit connection here at home, but I'm not going to saturate this pipe with any amount of traffic. Just for cost reasons, I selected basic. But the other ones basically allow you to go all the way up to 1.2 gigabits of throughput over VPN. So that's that's the tier, and then you associate this network, this gateway, with a network that you have in your subscription. This is grayed out because it's telling me there already is a virtual network gateway and a virtual network subnet on this subnet. This is the network we were just looking at, that /16. So that's why it doesn't let me pick it.
That's cool.
And then you just tell it if you want to use it. So in Azure, everything is an object. So you create a VM, you can create a public IP address. So you can point this to maybe a public IP address you've already used and allocated, or have this create a new public IP address. Because remember, this is going over the public internet. You need a public endpoint that your router on-prem can connect to.
Right. So let me ask you a question. When you create that new public IP address, is it automatically provisioned to be an endpoint for a VPN, or is there
correct? Yep. It's up. So we'll create the IP address, and then we create the we associate it with the VPN devices that we have that we set up for you under the covers.
Okay.
So remember, I said we do some trickery. It looks like a single device, but we have, we're running. It's a highly available service with an SLA. So we have an additional appliance kind of running a virtual instance running under the covers, so we can move that IP address around. So that's all done transparently. And there's also some options here if you were making use of route-based VPN with BGP. You can set up all your ASNs and so forth. I did not do that for my simple example here. And then the last two options are setting up your region and what subscription you want it to be deployed to. So if I go back to what I have deployed, so if I go back to my virtual network gateway, and you can see here that it's a route base, so just like I just showed you, basic. You can see this is my public IP address for this is the hanging out on the internet that that my Ubiquiti router is actually connecting to. I can also see some details of some traffic that's gone through. So in here, I mentioned our VPN gateway supports point-to-site connectivity, where you can have remote workers punch into this endpoint. In addition to having your office locations or branch office locations connect up into this also. I don't have any of those configured, but what I do have configured is the connection to my, from the cloud to my office. And you can see it's connected. I'm going to drill into this and let's see how this is actually created. Actually, what I'm going to do is I'm just going to go through and hit add and pretend like I'm making a new one.
Okay.
So in here, we give it a name. So
yeah.
My name, and you can pick, there's a couple of options here. One, ExpressRoute, again, same gateway. You can just pick the, whether or not this is a VPN or an ExpressRoute connection. The site-to-site is actually what I have configured for mine. Another option you notice in the drop-down is VNet to VNet. And
okay.
I'll talk a little bit about this when I talk about peering, because if you have two networks, maybe one in Europe and one in the West US, and you want to be able to connect them together, you could make use of a VPN gateway that you might already have deployed to be able to wire those networks together. But we have another vehicle to do that as well that I think is much better and more capable, and certainly more. I mentioned a VPN gateway max performance of 1.2 gigabits. Peering, which is something I'll talk about, is can be in the multiple gigabits of throughput that you can have between those locations. So, but that still remains an option and supported pathway to be able to connect up networks. So, so that's what this option is, basically connecting two Azure networks.
Yeah.
So, so site to site is what I have picked.
Yeah.
You pick. It's going to pick our gateway. The other thing, because I picked site to site, is going to have me pick what's called a local network gateway. And you can see that I already have one of these created. And let me think of the best way to actually show you what that looks like without getting out of the screen.
And how did you create that?
Yeah, that's what I was just going to go through and do, because it doesn't actually show you the properties of that. So I actually hit add and created a local network gateway. So when you define the VPN gateway, that's the endpoint that my router connects to in Azure. Azure needs to know about my local network, and what the public IP address is that I'm issued from Comcast, and also or Xfinity, whatever they call themselves these days, and then also the local address space to set up routing between the network in Azure and my home network.
Okay.
So this is what the network gateway looks like, and so I called mine Skynet on-prem Comcast. This is actually, this is the IP address of my router at home, and then I have my address space here at home, the 192.168.1.0. So you have to create that. So basically, we create the network gateway, we create the on-prem gateway, and then when we go back to that wizard where I was in the network gateway creating a connection, that's where you tie the two together. I'll go ahead and go back to that and hit add just so we can get back to where we were.
Okay.
So VNet to VNet, going to pick back site to site. And then it's going to ask you for the shared key. So this is that secret that you use to be able to allow you to connect, that allow the IPsec tunnel to be established. So that this prevents you from just arbitrarily connecting that endpoint.
Okay, that's fine. And do you make this key up here?
Yep, you make that key up. You can change it anytime. For the sake of not disclosing if I go here, if I click on that, it'll actually show me that key. But I can actually type, put in and change that key at any point in time. In fact, if I changed it here, it would actually drop my connection because my router is configured also with that same key. So,
right. Yeah. It's a shared key.
Yeah, exactly. So that's the gist of setting it up on the in the Azure side. This is actually my router.
Yeah.
Make this, actually, I talked about not disclosing my secret, and there it is. So anyway,
so anybody that's watching this probably won't see that because I'm sure that we can get Eric to blur that out.
Yeah, So just this one. Yeah, this is really the only thing I care about, I guess. But the so in here, this is the IP address of my peer. So this is actually going from my home into Azure. So this is actually my IP address of the network gateway in Azure. This is my local Comcast IP address, and this is actually the remote subnet that I'm setting up to. So that's how I've.
And was there a place in the Azure setup where we could actually see the peer address?
Yes. So if I go back to here,
right. I remember you showed me
55.165.1, and if I go back,
yeah. Okay.
So there it is right there.
And that's assigned.
That's correct. Yeah, that's correct. That was assigned by the public IP address that I had the wizard create when I created my gateway.
Okay.
So I have this when this loads. So what I've created, I have all of this traffic. I created what's called a virtual interface on my router, and this is actually well, it doesn't really have a lot of traffic going on right now. But this is actually the traffic going on against that virtual interface. So I can actually monitor, every once in a while you can kind of see that bump a little bit and see that there's traffic flowing over that. But that's effectively, bridging the two networks together. And let me just make sure that we're still connected. Yeah, it still shows connected. So we're talking right now.
Okay, perfect.
All right. So what I'm going to do, just to kind of show you in action, if we go back to my resource group, I have, like I said, this virtual machine. It's called Cyberdyne North 2. I already have a remote desktop connection to this, and let me pull up a couple things to show you, kind of prove it to you. Then I'm just going to go to networking on this thing, and you can see the public IP address 208.33. That's actually what I'm RDP'd into, and it has a private IP address. This is in that north subnet, if you recall, on my network. It has a 172.16.0.5 address. So I'm connected to this machine right now, and let me go ahead and just go to PowerShell here. See if I can try to make that a little bigger. Properties, font. All right. So what I'm going to do, the IP address of my router at home. You remember this is in a 172. Actually, I'm going to show you this first. IP config.
Yeah.
This is the IP address of my network in Azure. You can see my default gateway. This is actually, and this is why the IP numbering in Azure starts at .4, because there's a DHCP, there's a default gateway, DNS server. There's some IP addresses that we reserve on your network when you set it up. So the first VM that you deploy, first resource you deploy is going to have .4, .5, and so forth. So this is actually a second resource that I have. I shut down another VM earlier today, which had .4. So this one still has .5.
Okay.
So what I can do, though, from this VM, so 192.168.1.1 is actually the IP address of my router at home.
Okay.
And you can see is pinging. You can tell it's not immediately local because I have some a little bit of latency in that. And if I open up a browser, and just try to open that up, this is actually my router. So
yeah. That's cool.
Yeah, I have, this is actually network attached storage, 192.168.1.200. So I can, browse my network attached storage. So I'm using that tunnel for connecting my network in Azure to on-prem. So that's going from Azure to me. And I'm connected right now to the public IP address of my VM. It's common for customers not to maybe want a public IP on something that might have classified or important information, business critical information. So what you could actually do is not have a public IP address on that VM. And I'm going to actually I'm now back to my machine. And remember the IP address of that server is 172.168.0.5. And if I click connect, now I'm going from my machine connecting to the private IP address of that network in Azure over that VPN connection.
Okay.
So it works, bidirectionally. That's kind of the steps to get stuff talking, over VPN.
Awesome. That's cool, man.
All right. So let's say that within Azure, let me go back to slide here. A couple of slides from current slide. Okay. So let's talk a little bit, kind of take a step back and talk about what we've shown and what we talked about last time, and kind of taking it one step farther where customers might have a bigger environment in Azure and you want to connect things up. So I showed, bridging your network in Azure. Maybe you have other networks in Azure that you want to connect. I highlighted a little bit how you can do that. Remember when we created the gateway and I had the site-to-site and VNet to VNet. So that was one option that you could use as VPN or IPsec tunnels to connect up two networks in Azure. So let's kind of take a step back and talk a little bit about kind of what we did. So when you have a network in Azure, so remember my network also is a /16.
Yeah.
And you have multiple subnets in that network in Azure. We create a default route, we call a system route, that allows traffic to go from subnet to subnet. So you don't have to manage any routing tables in Azure.
Right. That automatically happens.
However, you can override that network table. So maybe you want to put something in the middle, traffic inspection device or a network virtual appliance. You can hijack that and pass traffic through that. But by default, we're going to allow that traffic to flow. However, if you have two networks, so this is actually showing, my network is /16. So just picture this being, two /16 networks that maybe they have different network numbers, but they're sitting in the same subscription in Azure. They cannot talk to each other. So there's no, it's a layer 3 software defined network. There's no, communication ability between these two networks unless you explicitly enable that. And one of the ways to do that is I showed you the VPN. So I said, some limitations with VPN, and that the highest throughput that you would be able to achieve is 1.2 gigabits. If I were to use the network gateway that I created, it's 100 megabits. So picture this cloud scale data center, massive amounts of capacity, and you have two VMs sitting on two different networks in Azure, and you want them to be able to talk. If I were to use that VPN gateway that I built to bridge that gap, my throughput between the two networks would be limited to 100 megabits. So that's not really that great of a use of kind of the resources we have in our data center.
Right.
VNet peering is the equivalent of saying, okay, I want to explicitly wire up these two networks with a virtual patch cable as long as the network numbers don't overlap with one another. The IP addresses and subnets don't overlap with one another. We don't advertise the bandwidth that you get between these, with VNet peering, but you can, I've seen, illustrations of being able to get, tens of gigabits of throughput between resources using VNet peering. Wow. Cool thing about VNet peering, well, this is actually showing that when you use VNet peering, it too injects routes, to be able to allow those two networks to communicate. Like everything else in Azure, there's a default one, that we put in. You can override that and hijack it with your own if you wanted to be able to put something in the middle. You can actually go across the subscriptions. So what I showed on the previous slide was two networks in the same subscription. Maybe you have two different subscriptions or two different regions. Maybe East US, West US, Europe, and so forth. So let's see how that works. So if I go back to my my network, my Skynet VNet, and if I go to peerings, I've created a mesh where I have my north network connected to the west. So I have three different networks. I have one in the east, one in the west, and actually four, and then one in the north and one in Europe. And I have them all pointing to one another. So I have this network is effectively connected to each one of these. So remember, the address space of this network, this is the one in the north, is 172.16.00. Let me just pick the one in Europe as an example. And the address space here is 172.19.00. Yeah. So they're non-overlapping IP ranges, right. And that allows me to connect the two. Yeah. So and just to kind of show how that works, if I were to remote desktop, I'm going to pick where's my VM in Europe. Oh, there it is. So I'm going to actually just connect up to that thing. And all right, let me go ahead and hit connect. Enter some credentials here. All right. So while this logs in, I'm going to open up my other RDP connection. I'm going to make the screen a little smaller. So this is the one that we have in North US. This is my VM that I have running somewhere in Western Europe. And let me just do an IP config on this thing, and you can see that the IP address is that 19. Actually, right here, the IP address is the 19. So I can't ping between these two machines because when the Windows operating system has the ICMP, the protocol, the mechanism to be able to send these test packets from machine to machine is actually blocked by the Windows firewall. But if I go in here and paste in the IP address of my other VM, the private IP address, you can see I can talk to it directly from my machine in Europe to my network in North Central US.
And you could probably do a net view or something like that.
Yeah, yeah. So I was thinking.
Yeah, that's going to fail.
Yeah.
Net space view space asterisk space // server IP address.
Okay.
No asterisk. You got to have a. Oh, no, wait. You're right. Just whack. Sorry. This is funny because just for our viewers out there, what's happening here is you've got two really old Microsoft guys trying to remember a legacy command for SMB.
All right.
I don't know if it's going to work or not. We'll see.
We'll
That
see.
port may be blocked.
Yeah. I can't remember if I have any resources shared on the other machine, but any event.
Yeah, it worked because it prompted
Yeah.
you for credentials.
Yeah, and what we do in that scenario, just to make it clear to the viewers, is that we're backhauling that over our network. We're not. Yeah, it doesn't. It is unhappy. So we're backhauling that over our private network. So picture IPsec tunnel going from my home to north central U.S. somewhere in Chicago, and then that VM communicating with resources in Europe, and that actually goes over our private network. So the only thing going over the internet is using IPsec, and it's going from my home to the VPN gateway, and everything else is private and encrypted in our network.
Okay. Cool. Yeah, that's awesome.
All right. So that was really all I had to show today. Hopefully that kind of shows, takes something that could be perceived as overly complex and shows how to wire it up. We can actually put in the show notes. This is if anybody wants to pick up one of these routers. This is actually now a supported router for Azure VPN connectivity, and there's a good walkthrough of basically what I have set up, and kind of some examples with different network numbers of how how that works. And you do have to set it up through the command line, because you have to set up some of the phase 1, phase 2 negotiation stuff a little bit differently than what's allowed in the UI that I showed. But anyway, that's it.
Okay, that sounds awesome. Listen, thank you so much for doing this. This is great, and this really helps. I think when we break it down step by step, people really get a lot out of it, and I certainly appreciate that. So, hey, next time you're on, I think we're going to talk about containers, which is kind of exciting.
Yeah, absolutely. Looking forward to it.
Yeah, me too. I think a lot of people hear a lot about containers, but nobody's really, or there's a whole group of people out there that would like to learn more about it. So hopefully, hopefully we can help.
Yeah, that's definitely a hot buzzword. Containerize everything. So we'll talk a little bit about what that is, what it means, and how to use it.
Okay.
Yeah.
All right. Well, guys, listen. Thank you so much for watching Taste of Premier. Hopefully you've subscribed. If you haven't subscribed, there's a button kind of around here somewhere. Maybe it's down there. I don't know. I have no idea. But anyway, that's your Taste of Premier.